Hi everybody and welcome to What If You Teleported to the Sun for 1 second and came back. The air is still. Your room is dim. Maybe your blanket's hugging your shoulders just right. And then, whoosh, you're gone. You don't feel the transition. You just suddenly are there. Floating. Suspended above a turbulent ocean of white-hot plasma. The sun, in all its rage, is below you. It screams in silence, because there's no air here to carry sound. The surface seethes at nearly 5,500 degrees Celsius, but the heat is nothing compared to the radiation. It's not warm. It's not hot. It's instant molecular betrayal. You're already not okay. Your skin tries to scream, but the air it needs to carry that scream doesn't exist. And in 1 single second, everything that makes you, is melting, unraveling, vaporizing, and being flung back to Earth in a tragic flash of quantum confusion. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And drop a comment telling me where you're watching from and what time it is right now, because somewhere, someone's trying to fall asleep to this madness. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You teleport with no suit, no ship, no warning. Just your regular pajamas, probably with some funny cartoon on them, now seconds from being reduced to atomic mist. You appear exactly 1 kilometer above the solar surface. Technically, the sun doesn't have a surface like Earth does, just increasingly dense layers of gas. But for simplicity, we'll say you pop into the lower corona, right above the photosphere, the bit we see glowing yellow from 150 million kilometers away. Here's where reality checks in. Even before your molecules get a taste of that fireball, the sun's gravity yanks on you with more than 27 times the strength of Earth's. If the vacuum doesn't get you, the fall will. But you won't fall. Not in a way that matters. In 1 second, you wouldn't even drop 5 meters. Instead, it's the radiation, like a billion gamma-ray bullets, that tears into your cells first. Historically, humans have always looked at the sun as a source of warmth, light, and divinity. The ancient Egyptians worshipped Ra, the solar god, believing he sailed across the sky each day in a golden boat. You, however, aren't sailing. You're disintegrating. Your skin begins boiling off almost immediately. Not melting, boiling. The outer layer lifts into gas before your nervous system can even send out a proper pain signal. Scientists argue whether you'd even feel pain at all. Some say it'd be too fast, others suggest your last moment might be one of searing agony. Let's zoom in, just for fun. Your blood is pressurized for Earth's cozy 1 atm environment. Out here. Zero pressure. Your blood doesn't know what to do with that, so it starts to boil in your veins, not because it's hot, but because there's no pressure keeping it liquid. It's called ebulism, and it's as brutal as it sounds. Meanwhile, your saliva and tears hiss away into vapor. The moisture on your tongue is gone. Your eyes? Yeah, they're no longer functioning or even recognizable. Your body's water tries to escape through every available exit like rats on a sinking ship. This is where things get almost beautiful. Your outer layers begin glowing. Literally. You are incandescent. For a sliver of a second, you shimmer like a candle wick caught in a supernova's breath. Somewhere on Earth, your atoms are already radiating back into space. You haven't even returned yet. Here's a fun tidbit. In 1958, the US Air Force sent a chimpanzee named Gordo into space. He survived the launch and achieved spaceflight, but his capsule's parachute failed on re-entry. Gordo didn't make it. It was one of the first times scientists saw how vulnerable life really is outside our atmosphere. Compared to you, though. Gordo got the VIP treatment. 1 second. That's all this is. The blink of a cosmic eye. But your atoms don't care. They're already scattering like glitter in a solar wind hurricane. The sun doesn't burn the way a fire does. It's nuclear fusion. Hydrogen atoms slamming into each other, fusing into helium, releasing unfathomable energy. You, for that moment, are part of that chaos. A tiny blip in a 4.6 billion-year-old process. Your brain. It tries to process what it's seeing. There's no light like this back home. Not from your phone, your lamps, or even a welding torch. The intensity of solar light here is over 500 times brighter than on Earth. But you don't really see it. Your optic nerves are fried before your retina can register the moment. Historians still argue whether ancient solar eclipses were terrifying omens or spiritual blessings, but for you, there's no debate. The sun is terrifying. Period. You don't even get to scream. There's no air to carry the sound, and your lungs are already ruptured. The absence of pressure outside your body causes internal pressure to win. Things pop. Not dramatically, but just enough to rupture what once held you together. And then, you're back. Exactly 1 second later. Back in your room. Blanket probably still cozy. But your molecules? They're not as they were. Not all of them made the round trip. One Mississippi. That's all it took. You don't have time to scream, or think, or beg. The universe doesn't care about your intentions, it only reacts to physics. And physics is very clear, your body is not built for this. The unraveling begins not like a cinematic explosion, but more like a quiet betrayal at the molecular level. Let's rewind that single second and slow it down. The first few microseconds, far less than the blink of an eye, are ruled by electromagnetic radiation. Ultraviolet rays, X-rays, gamma rays, they hit your body like a freight train made of light. These aren't the gentle UV rays that give you a sunburn at the beach. These are the type of rays that pass through you, mutating DNA, breaking molecular bonds, and ionizing your tissues. You're not just heating up, you're being transformed. Your atoms start losing electrons. This is ionization, and in the corona, where you've landed, everything's plasma. Not the blood kind. The physics kind. Plasma is the fourth state of matter, where electrons don't stay in their cozy atomic homes anymore. You've entered a realm where matter stops playing by your rules. Meanwhile, your outer layers start puffing outward. Like a balloon inflating into a vacuum, your skin blisters and peels back from the bone before you know what's happening. Except, there is no knowing. Your nerves are among the first to be fried. They simply can't send messages through ionized fluid. Pain, as a sensation, is skipped. Your body becomes a silent, disobedient sculpture, falling apart. Your internal organs, shielded only momentarily by your skin, aren't safe either. They begin cooking, again, not by heat conduction like in an oven, but by radiation penetration. X-rays zip through you and deposit energy deep inside, like bullets through jelly. Historically, radiation has had a strange relationship with humanity. Wilhelm Röntgen discovered X-rays in 1895, and within weeks, people were X-raying shoes, flowers, even their own skulls. For a brief moment, it was a parlor trick. Until the burns started. People lost fingers. Tumors grew. It took decades for us to respect the power of invisible energy. Now imagine that same energy, but 1,000,000 times stronger, pummeling every inch of you. Not just on the surface. Not just skin deep. Everywhere. There's also the problem of your atoms being forcibly separated. The sun doesn't just radiate, it emits solar wind. That's a stream of high-energy particles moving at hundreds of kilometers per second. Even if you're not blown away, per se, your molecules are being scraped off you like dust in a hurricane. Except this storm is made of pure ionized hydrogen, and you're the leaf. Here's a strange fringe tidbit for you. In the 1960s, some early astronauts worried they might accidentally teleport, or be yanked, into the sun due to strange gravitational anomalies. It sounds absurd now, but in the early days of space travel, the line between science and science fiction was blurry. Some even believed solar flares could temporarily open quantum doorways. While there's no proof of that, it makes your trip feel oddly familiar. Back to your body, the keratin in your fingernails. Gone. The collagen in your skin. Denatured instantly. Bones. They hold a little longer. But not long enough. The calcium phosphate that gives them strength begins to break apart at the subatomic level. Your skeleton becomes glow-in-the-dark dust. And yet, some tiny particles of you might survive the full second. Not because they resisted destruction, but because they simply didn't have time to fully vaporize. A few atoms from your toenail. A sprinkle of DNA too fragmented to function. Maybe an eyelash, carbonized like a burned match. Historians still argue whether the first nuclear tests in the 1940s marked the birth of the modern era or the first whisper of our self-destruction. What's certain is this: those tests taught us how fast matter can turn to energy. You, in this second, are undergoing the same lesson. Personally. What's remarkable, almost poetic, is that you're still you during this whole second. At least legally. The law tends to define death based on brain function or cardiac arrest. But you haven't been gone long enough for your identity to be erased in bureaucratic terms. You're both alive and completely destroyed. A walking paradox. Your brain, the seat of your personality, unravels layer by layer. Not like a balloon popping, but more like a sponge being squeezed dry and then microwaved. The myelin sheath on your neurons. Melted. The water in your brain tissue. Boiled. Your final thought, if you could call it that, wouldn't be a sentence. It'd be a feeling. A sudden, overwhelming wrongness. And here's the most tragic joke of all: time slows down under extreme conditions. Not for real, but for your perception. In moments of crisis, human brains have reported stretching seconds into minutes. So your last second? It might feel like an eternity. A warped, echoing awareness that something is ending. Let's not forget the vacuum. This isn't just empty space. It's actively hostile. Earth's atmosphere gives you pressure. Here, you have none. Without pressure, the nitrogen dissolved in your blood forms bubbles, like shaken soda exploding from a can. Your veins and capillaries burst open. Not with gore, but with fizz. Your mouth opens. Not to speak. Just a reflex. But there's nothing to inhale. No air. No help. The only thing entering your body is high-energy particles that treat your organs like soft targets. One final flourish. Your clothes. Cotton, polyester, doesn't matter. They vaporize nearly as fast as your skin. You're not the only one disintegrating. Your shoes are gone. Your glasses, if you wore them, melt. If you wore a wedding ring, the gold might survive as droplets for a few milliseconds before joining the metal-laced plasma. Then, silence. Not the peaceful kind. The cosmic kind. The kind where even atoms can't scream. You don't need to touch the sun to be destroyed by it. In fact, you don't even need to fall into it. Just hovering above the photosphere, what scientists generously call the sun's surface, is enough to unravel you layer by layer, cell by cell. And that's where we are now. Floating in fire. Suspended in impossibility. And your skin. It's the first ambassador to greet the horror. Skin is tough. You might not think so, but it's your body's first line of defense. It keeps moisture in, keeps microbes out, and even absorbs some UV light without complaint. But here, it's a paper umbrella in a nuclear hurricane. Let's break it down. The outermost layer of your skin, the epidermis, is about 0.1 millimeters thick. It's made mostly of dead cells packed with keratin. Under normal sunlight on Earth, it deflects just enough UV radiation to protect your deeper layers. But under solar conditions, it's gone almost instantly. Not burned in the conventional sense. Boiled. Exploded. As soon as your body's water content tries to escape, because of the vacuum and the heat, your skin blisters and rips apart like wet parchment in a furnace. The blood vessels in the dermis, just underneath, swell, rupture, and vaporize in microseconds. This isn't like standing too close to a bonfire. It's more like jumping into the heart of one. Fun historical side note: back in 212 BCE, the Greek inventor Archimedes was rumored to have used mirrors to concentrate sunlight and set enemy ships ablaze. Historians still argue whether this death ray was real or just legend, but the idea of harnessing solar energy to destroy isn't new. You're just living the ultimate version of it. Or, unliving it. Now, your hair. Let's take a moment for that too. Hair is made of keratin, the same tough protein found in rhino horns and fingernails. But it's not heat resistant. In this solar inferno, your hair blackens, curls, and evaporates before your scalp even gets a chance to register the loss. And speaking of hair, yes, all of it. Eyebrows, eyelashes, armpits, legs. Gone. You're as bald as a boiled egg before your body can even finish saying, ow. A fringe scientific tidbit. In the late 1990s, a group of researchers tried to simulate the effects of solar exposure on synthetic skin models. Their conclusion, even under Earth-filtered UV, human skin started to break down rapidly after a few hours. What you're experiencing right now is not filtered. This is raw sun. It's the solar equivalent of staring into an arc welder from 1 inch away, with your eyes open, and hoping for the best. Let's zoom in on a patch of your cheek. First, the sweat glands try to do their job. They're thinking, whoa, we're overheating. Let's sweat it out. But there's no point. There's no air to evaporate moisture into. Instead, the water in your pores boils, not by temperature, but by the drop in pressure. Blisters form. Then burst. Then vanish. Your sebaceous glands, those lovely little oil factories that keep your skin supple. They become tiny Roman candles. The oil ignites, pops, and hisses, releasing jets of vaporized lipids into space. It's kind of beautiful in a microscopic, horrifying way. You might wonder if any sensory input reaches your brain. Could your skin still feel? Technically, yes, for about 0.2 seconds. Then, the nerves are fried. Charred. Disconnected. And in those 0.2 seconds, the only signal your body receives is one of blind panic. Not pain, exactly. Something worse, confusion. A full system override. Here's a quirky thought, you don't smell anything. Your olfactory system is non-functional in a vacuum, and even if it weren't, your nose would be gone. But if you could smell something, it might be burning protein, a scent not unlike scorched hair mixed with sulfur and iron. People who've worked near crematoriums or in severe burn units describe it as unforgettable. So maybe it's a blessing that you don't register it at all. At this point, your outermost tissues have turned into a hot mist. The water, fat, and collagen molecules that made up your cheeks, lips, and neck are now part of the corona itself. You've become one with the sun, if only for a second. Back on Earth, ancient cultures tried all sorts of methods to protect the skin from solar damage. The Egyptians used a mix of rice bran, jasmine, and, get this, crocodile dung as sunscreen. Yup. Applied directly. They didn't understand UV rays, but they knew the sun could hurt. It's comforting, in a weird way, to know that even 5,000 years ago, humans were worried about the sun touching their skin too much. You've just taken that worry to the extreme. Now, let's move deeper, beneath the skin, to your muscle and connective tissue. These layers, designed to flex, contract, and hold everything together, are being systematically unzipped. Protein strands like actin and myosin, which let you move, are breaking apart. Not slowly. Not like in a fever. They're denaturing, curling up into useless blobs. Imagine spaghetti boiling until it dissolves. Now imagine your muscles doing that, mid-flex, while you hover helplessly in an invisible soup of radiation. And your blood? We're saving the deep dive for later, but for now, just know this, with every heartbeat, which only happens once, maybe twice more, your circulatory system is pumping what little liquid remains toward vessels that are already burst open. There's nowhere for it to go. It leaks out into the vacuum, turns to mist, then vanishes into the solar wind. What's left? Skinless, scorched muscle stretched over bones already trembling from the heat. Your skin was supposed to be your armor. It was your shield. Your climate control. Your boundary with the world. And in 1 second, it's entirely gone. All of this, mind you, is happening without a single sound. Not because your ears are gone, though they are, but because the sun's realm has no air. There's no breeze. No roar of flames. Just you, and silence, and disintegration. Your bones were never supposed to see the light of day. And yet, here they are, exposed. Glowing. Cracking apart at the seams. Because even after your skin and muscles have dissolved into ionized soup, your skeleton still stubbornly holds on, as if refusing to believe it's next. But the sun has no patience. Bone, for all its rigidity and strength, is no match for the intensity of this place. It's built primarily of calcium phosphate crystals woven with collagen protein, a structure that gives your body shape and allows you to walk upright, type on a keyboard, or hold your favorite mug in the morning. But here, 1 kilometer above the sun, all of that elegance collapses in on itself. The collagen, already fragile at high temperatures, begins to carbonize in under 1/10 of a second. This isn't a slow roast like in a cremation chamber. This is instantaneous pyrolysis, the breaking of chemical bonds under extreme heat. Your bones char and blister from the inside out. In fact, your skeleton starts to glow faintly, an eerie bluish-white, like hot glass. This is called blackbody radiation, and it's a fancy term for how objects emit light when they're hot. And in this case, you're very hot. There's a quirky scientific anecdote from 1930s Germany where researchers trying to measure extreme bone heating accidentally set a sheep skeleton alight in a vacuum chamber. It wasn't supposed to happen, but the speed of structural collapse under sudden radiation exposure caught everyone off guard. A chilling foreshadowing of what you're experiencing now. Each rib fractures, not with a snap, but with a silent burst, like dry twigs exposed to lightning. The spongy bone inside, called trabecular bone, evaporates faster than the denser outer layer. That soft bone inside your vertebrae? Gone in a flash. The sun doesn't burn like a fire, it strips things to their elements. Carbon, oxygen, calcium, all ripped apart by energy levels the human body can't comprehend. Historians still argue whether the earliest mummies, like those in the Chinchorro culture of South America, were preserved more by desert heat or by ritual preparation. But even the driest desert heat on Earth is laughably weak compared to what's happening here. Mummies last millennia. Not even milliseconds. Let's move to your teeth, shall we? Teeth are among the hardest substances your body produces. Made of enamel, they can survive centuries in graves, long after flesh and bone have faded. But in the face of the sun's raw power, your molars pop like candy in a campfire. The tiny air pockets inside your enamel expand violently. Microfractures race across each tooth before they explode outward, flinging microscopic flecks of calcium into the radiant storm. And your skull, oh, your poor skull. It holds the most precious cargo you have, your brain. We'll get to that part later, yes, it gets its own spotlight. But right now, the skull is collapsing. The sutures, the seams that once connected its plates like puzzle pieces, have given up. They warp under thermal expansion. Think of rivets popping on an overheated spacecraft. That's your cranium now. By the halfway point of this single second, your body has lost structural integrity. You're not even a human figure anymore. You're a partial silhouette of glowing embers and unbound atoms. You haven't fallen into the sun, you've joined it. Here's a weird philosophical thought, are you still you if your entire body becomes part of a star? A fringe tidbit, in fringe esoteric circles during the 1800s, some mystics believed the sun was a conscious, divine being, and that by touching it, your soul could be purified. They'd be thrilled to hear you made the trip. Though they probably imagined a more spiritual cleansing, not an atomic one. Your spinal column, which once stood tall to help you reach for the stars, is now twisting unnaturally, breaking apart like scorched matchsticks. Your pelvis, often the strongest single bone structure in the body, splits down the middle as internal gases expand and force their way out. And if you had any metal on you, dental fillings, piercings, implants, they may have temporarily held shape longer than your tissues. But by now, even metal is beginning to sublimate, the phase where solids skip straight to gas. Not even the laws of matter feel stable here. At this point, your skeleton isn't just breaking, it's disappearing. Atomic bonds are being destroyed. Nuclei are absorbing energy and re-emitting it violently. In the corona, matter behaves like light, and light behaves like a bulldozer. You're caught in a feedback loop of disassembly. Here's something fun and terrifying, under the sun's ionizing energy, elements can be transformed. This process is called nucleosynthesis, usually reserved for stars themselves. You're not just burning. You're becoming new matter. Your atoms, with the right conditions, might even fuse. A hydrogen atom in your blood could meet another and, with enough pressure and energy, become helium. That means, somewhere in that flash, part of you literally becomes part of what powers the sun. Suddenly, you're not just visiting the sun. You're inside it. Interacting with it. Rearranged by it. Back on Earth, forensic scientists often use bones to identify remains after fires or plane crashes. But in your case, there are no bones left to analyze. There's no charred femur to recover, no skull fragments to examine. You're not recoverable. Historians still argue whether early cremations in ancient India were more about purification or practicality. Either way, cremation on Earth takes about 2 to 3 hours at 1000 degrees Celsius. The sun has you fully vaporized in under 0.7 seconds. It is, undeniably, the ultimate cremation. And yet, time moves forward. The second isn't done yet. Just when you thought there was nothing left, we go even smaller. Because the skeleton is only the halfway point. Beneath that, beneath everything visible, are cells, atoms, and subatomic particles, and they're about to be rearranged in ways nature never intended. That's next. You're not burning. You've gone past burning. Burning is what happens when oxygen combines with matter and creates flame. But there's no oxygen here. You're in a vacuum, a hot, unforgiving, light-soaked vacuum where flame can't exist the way we know it. What's happening to you isn't combustion. It's ionization. That's right, your atoms are being ripped apart, their electrons stripped off by the relentless flood of solar radiation, magnetic fury, and heat that makes every fire on Earth look like a birthday candle in a windstorm. Right now, your body is no longer you, in any biological sense. You are becoming plasma, the same glowing soup that the sun itself is made of. A fourth state of matter, beyond solid, liquid, and gas. Plasma is what happens when atoms can't hold on to their electrons anymore. When the rules of polite, structured chemistry break down. And you? You are soup now. Each of your atoms, the hydrogen in your water molecules, the carbon in your bones, the iron in your blood, is undergoing forced exile. Electrons, blasted off by ultraviolet and X-ray photons, flee their orbits and become part of the solar wind. What's left behind is a hot, unstable soup of nuclei and free electrons, tangled in chaos. It's not a clean transformation. Plasma isn't peaceful. It's electromagnetically violent. Charged particles whip around the sun's magnetic field at absurd speeds. The sun's corona, where you're floating, or what's left of you, is threaded with invisible magnetic loops that twist and snap like electrified spaghetti. Any piece of you caught in those lines is accelerated, flung, or pulled apart like taffy in a nuclear centrifuge. Here's a fringe fact: in 1973, a Soviet spacecraft called Prognoz-1 observed magnetic reconnection events in the solar corona, brief bursts where magnetic lines snap and release insane amounts of energy. If you materialized near one of those bursts, you'd be reduced to elementary particles in less than a nanosecond. But hey, you lucked out. You only got the regular disintegration package. Your remains are now a plasma cloud. This cloud is faint, but real. If a high-resolution sensor were watching, it might register a localized blip, something that wasn't quite solar, wasn't quite space junk, but wasn't nothing either. You're radiating now. Emitting. Every part of you is releasing photons, packets of light, into every direction. Not just visible light. Infrared. Ultraviolet. X-rays. Maybe even gamma. You've become a glow. Let's talk about your blood, just for a moment. It used to be your delivery system. Oxygen, sugar, hormones, all carried by red and white cells on rivers of plasma. But now, your blood is also plasma, just the other kind. The sun's kind. Your hemoglobin, once lovingly holding onto oxygen molecules, has been obliterated. The iron atoms inside, yes, you literally had metal in your blood, are now ionized, glowing hot, and dispersing into the solar ether. And this is the strange poetry of it all: stars created those atoms in your body billions of years ago. Every bit of calcium in your bones, every atom of oxygen in your lungs, was forged in some other star's death. And now, you've returned home. Well, kind of. Let's not get too sentimental. This is not the romantic, becoming stardust, moment poets dream about. This is physics in its rawest, most brutal form. Historians still argue whether early astronomers like Galileo truly understood the terrifying scale of the sun, or if they underestimated it as just a ball of fire. Galileo saw sunspots, yes, but he also went blind observing them. That's the kind of warning sign humanity tends to ignore until it's too late. Let's peek closer at what happens to your carbon atoms, shall we? Carbon is the backbone of life. It links up with other elements to form everything from DNA to marshmallows. But here, unprotected, your carbon atoms are being disassociated. That means even the nuclei themselves, the protons and neutrons inside, are being battered by high-energy photons. You're not just losing structure. You're losing identity. At these energy levels, photodisintegration becomes possible. That's when gamma rays hit an atomic nucleus so hard that it splits apart. So your carbon might become helium and beryllium, your nitrogen might fragment into protons and neutrons, and your phosphorus? Well, it's not doing great either. You're being simplified. Reduced. Returned to base materials. A quirky fact, inside particle accelerators on Earth, scientists fire protons at atoms just to watch them break apart and learn what's inside. That's happening to you now, but without a lab coat or an audience. It's just you and a star that's been cooking for 4.6 billion years. And this is important, the sun doesn't even notice. It doesn't flinch. You could teleport a school bus into this exact spot, and it would vanish just as quietly. That's how big and energetic the sun is. It devours without reaction. So what's left? A few trillion particles from what used to be your body. Scattered. Some drift upward, blown away by solar wind at over 400 kilometers per second. Others fall downward, briefly dancing through magnetic fields before they're swallowed into the convection zone and never seen again. You're both everywhere and nowhere. Historians still argue whether the soul, if it exists, can survive death in any form. But if it does? And if it's tethered to the body in any way? Then it's safe to say it's been flung into pieces and vaporized alongside your atoms. Maybe it's floating through the corona. Maybe it's riding a solar flare on its way to Saturn. Or maybe, just maybe, your consciousness, however briefly, felt the sensation of becoming light. And now, that second is nearly over. But before we head back to Earth, you might be wondering, will anything of you survive this? The answer is next. Your eyeballs never had a chance. Before your bones splintered, before your skin boiled away, before you were a cloud of plasma and shimmering atoms, your eyes were already gone. Not melted. Not burned. Unmade. You might think the sun's intense heat would be the main problem, but the real horror here is light, pure, concentrated, radiation-laced light. The kind that turns glass opaque, blinds sensors, and cooks satellites from thousands of kilometers away. Your eyes, those soft, liquid-rich spheres delicately tuned to Earth's mild sunbeams, are assaulted within nanoseconds. The cornea, normally just tough enough to protect your iris and pupil from a bit of dust and UV, goes first. It dries, warps, and shatters like a frozen windshield under a blowtorch. Then the aqueous humor, the fluid behind your cornea, boils. Not from heat alone, but from lack of pressure. In the vacuum surrounding the sun, all liquids in your body try to escape at once, expanding rapidly into steam. Your eye pressure spikes, then implodes. A pop would be the polite way to describe it, but there's no sound, just sudden liquefaction and dispersal. And then, behind that, your lens, that crystalline dome that flexes to focus light, superheats and fractures. You can almost hear it crack like sugar glass, except you can't, because your auditory system is already fried. The retina, the precious film of cells that captures light and transmits it to your brain, is gone before it gets a chance to scream. It's not just the brightness. It's the photon pressure. That's right, light here actually exerts a small, physical force. It's enough to push on solar sails in space. And for your soft, squishy retinas, it's a violent barrage. Light doesn't just pass through your eyes. It slams into them, like a trillion bullets made of energy. And even before all of that, before your eyes physically fall apart, they've already stopped working. Light at this intensity overloads the optic nerve instantly. You know how staring into the sun on Earth for a second gives you spots in your vision? This is the infinite version of that. You'd be blind before the vaporization even began. Ancient cultures, perhaps sensing the danger, built elaborate myths around the sun and vision. In Greek mythology, Helios drove a fiery chariot across the sky. His son Phaeton once tried to steer it and failed, crashing and burning the earth in the process. Historians still argue whether this was an allegory for meteors, drought, or the dangers of pride. But symbolically, the message is clear: mortal eyes are not meant for godlight. Interestingly, your eyelids might be the last soft tissues to go. In a moment of primal reflex, they clamp shut. The muscles around your eyes fire a final command to protect your vision. But eyelids are just thin skin. They shrivel like tissue paper before they can offer any mercy. There's a fringe scientific theory, rarely discussed, that in extremely short, high-energy bursts, like those produced in laser experiments, some light can cause spontaneous internal breakdown of retinal tissue without any surface heat. In theory, your brain might not even register the pain. It might just receive a final, brilliant flash, the brightest you could ever perceive, before the darkness becomes permanent. This final flash is probably meaningless. By the time your brain interprets anything, it's already half melted. But it's poetic, isn't it? Your last visual experience is pure white. Not because of clarity, but because everything is being saturated. Your visual system is essentially electrocuted by photons. And while we're at it, let's visit your optic nerve. This fragile cable that connects your eyes to your visual cortex is a bundle of myelinated axons, little signal highways, wrapped in fatty insulation. That fat is flammable under solar conditions. The sheath burns first, then the axons fry. No signal can pass through. You're blind, but more than that, you're disconnected. Historians still argue about the strange blindness that struck early astronomers who stared too long at solar eclipses. Was it retina damage? Or a neurological illusion caused by contrast fatigue? Either way, they at least had an atmosphere and a few filters. You have neither. Let's not forget the other senses that relied on your eyes. Balance? Gone. Your eyes help orient you in space, and now space itself is unrecognizable. Orientation here is meaningless. There's no horizon. Just blinding intensity in all directions. Up and down are abstract concepts. If you could still perceive anything, you'd be floating in dimensionless radiance. But the radiation doesn't stop with your vision. X-rays pass directly through your head. They tear through soft brain matter and bounce inside your skull like a pinball machine. Each bounce deposits heat and energy, frying neurons as they go. The optical parts of your brain, the occipital lobe, are among the first to suffer. Even if your eyes survived, your brain wouldn't be able to process what they saw. There's a quiet tragedy in that. You were built to observe. Evolution gifted you with eyes that see color, detect movement, read faces. All of that, millions of years of adaptation, is undone in less than 0.01 seconds. You saw nothing. Or worse, you saw too much. Fun fact, the iris of your eye contracts in response to light to protect the retina. But here, it doesn't matter. The iris doesn't contract. It shrinks away from heat and radiation, like paint peeling under a blowtorch. There's no protection here. No squinting. No shade. No miracle. And now, all that remains of your face is an empty cavity. Where once there were eyes filled with curiosity and starlight, now there's just collapse. No sockets. No lashes. Just scorched bone and a plume of evaporated fluid. Somewhere in the data logs of the Parker Solar Probe, a NASA spacecraft launched to touch the sun, is a model of solar radiation so intense it could melt steel in moments. You went closer than that probe ever will. And you had no shield. You blinked, and lost everything. And now, with your face gone and vision turned to memory, it's time to ask the next question. How do you breathe in a place where air doesn't exist? Spoiler, you don't. You take a breath, but nothing comes in. Not because you forgot how, but because there's nothing to breathe. No oxygen. No nitrogen. No cozy mix of gases your lungs have spent a lifetime inhaling. Out here, just above the sun's surface, the atmosphere has long since vanished. This is vacuum, the most inhospitable version of empty the universe offers. And your lungs? They're panicking. The moment you teleport into the sun's domain, your chest instinctively tries to inhale. It's reflexive, built into your brainstem. Even if your conscious mind is screaming, don't breathe. Your body doesn't listen. It demands air. And it opens the door to the void. The result? Explosive decompression. You've probably heard that phrase in movies, but let's break it down, quietly, gently, as you float in the last second of your life. Inside your chest, the air pressure is still Earth normal, about 14.7 pounds per square inch. Outside? Essentially zero. The instant your mouth opens, that pressurized air in your lungs bursts outward, desperate to escape into the vacuum. Your alveoli, those delicate little air sacs where oxygen enters your bloodstream, rupture like soap bubbles. Your trachea tears. And your throat, lined with mucous membranes not designed to handle any of this, dries out and splits within milliseconds. If this weren't the sun, you'd be dead just from that. People exposed to vacuum, think of astronaut suits failing, usually lose consciousness in 15 seconds. But you don't have the luxury of time. Meanwhile, your blood begins to boil. Not because it's hot, though it is, but because liquids boil in a vacuum even at room temperature. The pressure that normally keeps your fluid stable is gone. Your blood vessels swell, then burst, spraying superheated mist through your body. Your heart. It manages maybe one last beat. But it has nowhere to pump to. Everything is bleeding, everywhere, internally and externally, at once. A quirky space fact: NASA once tested rapid decompression on animals in the 1960s to simulate vacuum exposure. One poor test subject, a chimpanzee named Ham, lost consciousness in 14 seconds but was revived. You're not coming back. Let's zoom in on your lungs. The bronchi, the tree-like branches that deliver air, are now twisted, empty tunnels. The lining sloughs off, and what little tissue remains is sterilized by ultraviolet light. Sterilized is a kind word. The better term might be obliterated. And remember the oxygen in your bloodstream? That's gone now. Every red blood cell has been fried, ruptured, or shredded. The iron inside them, the stuff that makes your blood red, is glowing faintly, forming part of the radiant cloud you've become. Historians still argue whether early divers in the 1800s truly understood the bends, a condition caused by nitrogen bubbles forming in the blood during rapid ascent. But you're experiencing the cosmic version of that, your entire vascular system fizzing into foam and disappearing into solar radiation. There's a moment, just a flicker of it, where your body still tries to exhale. As if it can push out the death. Expel the vacuum. It's an empty gesture. There's nothing left to push. The diaphragm spasms. The chest cavity collapses. Your voice, if it even existed in that moment, would have no air to carry it. You couldn't scream even if you wanted to. And yet, your mouth still opens. Perhaps as reflex. Perhaps as protest. Perhaps to ask a silent question the universe doesn't bother answering. Back in the 1950s, a fringe group of scientists once believed there could be breathable zones above the sun's surface, places where advanced life might hide in magnetic bubbles. Of course, this was fantasy. But it reminds us of something deeply human, our stubborn hope that somewhere, even in hell, there might be air. There isn't. Now, let's consider what this means for your brain. Because with no oxygen, and no pressure, and no working lungs, hypoxia sets in. This is when your brain cells begin to die from lack of oxygen. But you're not just hypoxic. You're irradiated, boiled, and depressurized. Your neurons aren't dying, they're exploding. Still, for a brief moment, just a sliver of this second, your brain might flicker. A final gasp of awareness. Some survivors of near drowning or suffocation describe an overwhelming calm, a tunnel of light, even visions. But in your case, that tunnel of light is the literal corona of a star trying to kill you. Your brain, in its final milliseconds, might mistake death for enlightenment. There's a strange comfort in that. Let's not forget your ears. As pressure drops to zero, the air in your middle ear expands violently. Your eardrums burst. There's no pain, your sensory nerves are already gone, but there's a sudden emptiness. A release. Like all the sound in the universe just evacuated. And now, your voice. It's gone. Not just from lack of air, but from structural collapse. Your vocal cords have unraveled. The cartilage that held your larynx together has split into chemical vapor. You could try to hum, to whisper, to call out to a god you hope exists, but it wouldn't matter. Out here, nobody hears you disappear. Even the sun isn't listening. And still, the second continues. What's next? We go deeper. Because inside your ribcage, in a chamber of steam and ash, your heart is about to beat its last. Your heart has always been stubborn. For all the chaos happening outside, blistering heat, searing light, boiling blood, it still tries to do its job. One final contraction. One last push. Maybe it thinks it can save you. It can't. Your heart isn't just a pump. It's a muscular organ wrapped in 4 chambers, crisscrossed with arteries and veins, connected to everything in your body like a central hub. For decades, it's thumped away, sometimes calm, sometimes fast, always trying to keep rhythm with your life. Now, it skips. Not because it's tired, but because the electrical signals that drive it are gone. Just, gone. Let's rewind a half second, to when you first arrived. At that exact moment, your nervous system fired off a panic cascade. The sympathetic, fight or flight, response. Adrenaline surged. Your pupils dilated, blood vessels constricted, heart rate skyrocketed. It tried to keep you alive in the most inhospitable place imaginable. But this isn't a fight or a flight. This is a freefall into stellar entropy. By now, the myocardium, the thick muscle wall of the heart, has reached temperatures it was never designed to survive. It isn't just cooking. It's denaturing. The proteins inside are folding the wrong way, falling apart like a wet origami crane. The tissue blackens. Tightens. Then tears. And then, the last beat. Not a strong thud. More like a tremor. A twitch. The ventricles convulse, flinging nothing into vessels that no longer hold pressure. Blood has turned to gas, arteries have collapsed, and the aorta, the body's largest artery, is peeling apart from within, like a fire hose left under a flamethrower. A fringe medical tidbit: in extreme cases of electrocution or heat stroke, the heart can go into ventricular fibrillation, a chaotic rhythm that mimics seizure. For a split second, yours might too. But there's no shock paddles in space. No doctor yelling, "Clear." Just you, floating through oblivion, pulseless. And now, let's talk about the pericardium, the sac around your heart. It's supposed to protect your heart, provide lubrication. But here, it's nothing more than a tissue balloon filled with boiling mist. It bursts. Like everything else. Ancient civilizations thought the heart was the seat of the soul. The Egyptians weighed it against a feather. The Greeks believed it was the center of reason and emotion. Historians still argue whether early philosophers were being poetic or if they truly thought the heart thought. Either way, the sun doesn't care. It erases hearts just like it erases comets. Meanwhile, your nervous system, which controls every beat, every breath, every tiny reflex, is unraveling. Your brain stem, where your survival instincts live, is flooded with static. Neurons misfire in disorganized chaos. Synapses dissolve. And yet, your vagus nerve, the long strand that helps regulate heart rhythm and digestion, might fire one last time. A desperate plea for homeostasis. A final whisper of, calm down, even though you are literally melting. Quirky science fact: the heart can continue beating even when removed from the body, as long as it has oxygen. But you have no oxygen. You're beyond medical miracles. Your body is a vacuum-crushed solar artifact, not a patient. Even your bones around the chest can't offer protection now. The rib cage is gone. Sternum vaporized. Lungs turn to foam. There's no thoracic pressure left. Your circulatory system is a collapsing balloon. But here's something wild to consider. The atoms in your heart, carbon, nitrogen, hydrogen, were once part of a cloud of interstellar dust. Billions of years ago, they drifted in a nebula, waiting to be born into something. They became your chest, your blood, your first heartbeat as a baby. And now, they're returning to their cosmic origin. This is not death. This is re-entry into the solar story. And the iron in your blood? Oh yes, let's not forget it. The heme group in hemoglobin contains a single iron atom. It's what makes blood red. That iron is now ionized, glowing, being swept into solar loops. If it survives long enough, it might even join the solar wind, a constant stream of particles flying away from the sun at 400 kilometers per second. You might end up, in some ridiculous poetic twist, raining down on Mercury. Let's reflect on your final heartbeat. It wasn't your best. It wasn't clean. It wasn't heroic. It was reflex. Automatic. Pointless. But it happened. And then it stopped. And with that final contraction, your body ceases to be a system. There's no more circulation. No more internal signals. No more response. From here on, it's disassembly at the molecular level. In the vacuum above the sun, nothing rests. Nothing sleeps. Everything vibrates, ionizes, flows. And now that your heart has stopped, there is nothing left inside you holding things together. And yet, even as the light consumes every part of you, something lingers. The tiniest particles. The most stubborn remnants. The subatomic ghosts of who you once were. They're still here. And they're next. Let's zoom in. No, closer than that. Past your skin, long gone. Past your bones, disintegrated. Past the heart that once pulsed with the rhythm of life. Let's go all the way down, to the smallest things still holding their shape. Subatomic particles. At this stage, you're no longer a person. You're a cloud. A blur. A smear of atoms unbound and scattered like dust in a sunbeam. But even dust would be jealous, because what's left of you isn't even whole atoms anymore. Your electrons are long gone. They were the first to flee, stripped from your atoms the moment you arrived. Ionization took care of that. What's left, what's still, you, are bare nuclei, protons and neutrons, all alone, exposed to the wrath of the sun. And the sun is just getting started. Each of these particles was once part of a carefully arranged structure: carbon, oxygen, hydrogen, iron. They bonded into water, protein, DNA. But now they're free-floating components, scattered across a swirling chaos of radiation and magnetic loops. You are not dissolving. You are deconstructing. Let's pause on the protons for a moment. They're tough little things. Stable. Survivors. A proton can live for billions of years. The ones inside you are as old as time, forged in the Big Bang, reshaped in stars, passed from meteorites to molecules, and now, they're back in the furnace. Right now, some of your protons are fusing. That's right, nuclear fusion. It's what powers the sun, and now, in a strange twist of cosmic irony, you are participating. A proton from what used to be your muscle might collide with another from a drop of your blood. Under enough pressure and heat, they fuse. The result? Helium, the element of stars. Congratulations. You've just become energy. This process releases gamma rays, the most energetic form of light. Invisible, unstoppable, and violent. Some of these rays might travel for 100,000 years through the dense layers of the sun before finally escaping into space, carrying with them the last faint whisper of your existence. That's your afterlife, a photon on a centuries-long journey. But not all your particles are that lucky. Some are ripped apart further. Let's visit your neutrons. Neutrons, neutral in charge, are normally stable inside an atom. But alone? They decay. Quickly. With no protective atom to hold them, your lone neutrons begin to transform. They emit electrons and morph into protons, a quiet process called beta decay. Yes, your atoms are still changing, even in death. Quirky science tidbit: in rare cases, scientists have trapped individual neutrons to watch them decay in labs. It takes about 15 minutes for a free neutron to fall apart. But here, in the sun, that time compresses. The energy is so overwhelming that decay isn't a slow fade, it's a violent shatter. You've become unstable in every sense of the word. Historians still argue whether the earliest physicists, Bohr, Rutherford, Curie, fully grasped how devastatingly impermanent matter really is. They discovered radiation, yes. But did they imagine that one day, a human being might be teleported into a star and torn apart by those very forces? Probably not. But here you are. Even your quarks, the building blocks of protons and neutrons, are under attack. Normally bound by the strong nuclear force, the most powerful force in the universe, they're holding on tight. But in extreme energy environments, even that bond can be tested. There's a hypothetical state of matter called quark-gluon plasma, believed to have existed just after the Big Bang. It's what happens when protons and neutrons melt, and their quarks swim freely in a chaotic soup. For a fraction of a second, some part of you might be approaching that state. That's how deep this goes. You're being unwritten on a level lower than chemistry. Lower than physics. You're becoming a thermonuclear rumor in the sun's endless conversation with itself. And yet, despite all of this, there's still no noise. It's completely silent. Sound can't travel here. There's no air to carry vibrations. All of this, the boiling, the breaking, the unwinding of atoms, is happening in total silence. No screams. No explosions. Just the quiet fury of physics doing its job. A solar physicist once described the corona as a place where matter forgets how to behave. That's you now. You're not behaving. You're spreading. Dissolving. Joining the dance of hydrogen and helium that's been ongoing for billions of years. And the sun? It doesn't notice. It never does. You are one whisper in a bonfire. One speck in a cathedral of flame. And now, the last pieces of you are drifting. Some are falling deeper, into the chromosphere, the layer just beneath the corona. Temperatures are still high, but the particles are denser here. If any part of you enters this layer, it might slow slightly, caught in eddies of magnetism and heat, before spiraling down into the convection zone. Others escape, pushed outward by the relentless force of solar wind, a stream of charged particles that races through the solar system. If that happens, tiny pieces of you, ions and photons, might eventually pass Mars. Maybe even reach Earth again. You could become part of a northern light. Auroras, those shimmering veils of green and red near Earth's poles, are caused by solar particles colliding with our atmosphere. They spiral along magnetic fields, light up the sky, and make children gasp. Maybe, just maybe, a tiny ion that used to be your fingernail finds its way home that way. Historians still argue whether ancient people truly understood auroras. Some thought they were spirits, others thought they were omens. No one thought they were people coming home from the sun. But here we are. And still, this second isn't over yet. One final question remains: what if someone watched this happen? Imagine someone watching. Not from Earth, of course, you're far too close to the sun. Even our most powerful ground telescopes couldn't resolve something the size of a person against that blinding inferno. But maybe from a probe. A satellite. A machine with sensors fine-tuned to light and heat and the strange behavior of particles under pressure. Let's say the Parker Solar Probe saw it. Launched by NASA in 2018, this spacecraft was designed to get closer to the sun than anything before it. Wrapped in a special carbon composite heat shield, it dips into the sun's corona again and again, measuring magnetic fields, charged particles, solar wind speed. Now imagine it caught a glimpse of you. Not your face. Not your form. Just, the anomaly. A sudden bloom of high-energy particles where there shouldn't be one. A flash of soft X-rays, out of place. A hiccup in the electromagnetic field, like a pebble dropped into a tidal wave. Nothing dramatic, just a ripple. But to an onboard computer, that ripple stands out. It doesn't match the models. The algorithms flag it. Scientists back on Earth receive the signal, buried in a torrent of other data. Someone blinks at their monitor and frowns. A postdoc in Pasadena, sipping coffee at 3 a.m., mutters, "Huh. That's weird." But they don't know it was you. They run simulations. Maybe they write a paper. Localized plasma anomaly in Parker Orbit 56. It gets published. Read by 7 people. Cited twice in the next 5 years. No one ever connects the dots. Because the human brain refuses to believe that anything could simply appear next to the sun. But let's say they knew. Let's say they watched it happen in real time. A human figure, suddenly emerging from nowhere, floating alone in solar space. For exactly 1 second. A body, then a glow, then a cloud, then, gone. What would they feel? Shock, obviously. Horror. Maybe helpless awe. But more than anything, confusion. Because nothing survives the sun. Not people. Not machines. Not hope. And yet, there you were. The silhouette wouldn't last long. Within milliseconds, the light would overwhelm every camera. The sensors would saturate, registering only brightness. If an AI tried to stabilize the footage, it might produce a ghostly outline, a brief, humanoid shimmer against a background of pure energy. Then, silence. And yet, the probe would keep recording. Because that's what machines do. It wouldn't care that it just witnessed the death of a conscious being. It wouldn't mourn. It would simply log the data, timestamp it, and keep flying. The sun, meanwhile, wouldn't flinch. Its surface would keep roiling. Flares would continue. Loops of plasma would rise and fall like tidal waves. Sunspots would form and vanish, uncaring. It has swallowed entire planets before. What's one person? You be a statistical outlier. A flicker in the noise. A fringe theory might emerge on a Reddit thread. What was that thing Parker saw? A few conspiracy theorists would argue it was a test subject. A few sci-fi fans would spin it into a short film. But serious scientists would shrug. Because in space science, one data point means nothing. And yet, if someone had seen it, really seen it, they might be changed forever. Not by your death, but by the absurdity of it. The sheer audacity of teleporting a human to the sun. For 1 second. And bringing them back. That's right, bringing them back. Because the scenario wasn't teleport and die. It was teleport to the sun for 1 second and return. So, what returns? Let's talk about that. A full second has passed. Exactly 1 second. Your atoms, most of them, are gone. Blasted into ions, fused into solar particles, or spread across magnetic fields. Your bones, blood, organs, mind, all unmade. But if this were teleportation, true teleportation, then we have to assume there's a return trigger. And now it fires. What comes back? Certainly not you. At least, not intact. Let's be generous and assume this isn't sci-fi teleportation where you're just reconstructed based on some perfect quantum snapshot. No. This is you, physical matter, disappearing from one place and reappearing in another. But most of your physical matter has been vaporized. What returns, then, is the pieces. Ashes? No, ashes require combustion. This is finer than ash. This is atomic scatter. Maybe a faint puff of gas. Maybe a drop of superheated plasma, collapsing midair the instant it appears. If your return spot is on Earth, say, a laboratory room or testing chamber, it's now filled with a hiss of superheated vapor. The room lights flicker. The air ripples. Instruments beep confusedly. A few drops of liquid metal, what used to be fillings in your teeth, hiss as they hit the floor. There's no body. No shape. No eyes or heart or skeleton. Just evidence. Scorch marks. Radiation. Residual heat. And questions. Because those in the room were watching a monitor that said, human returned. But what they got wasn't human. It was proof that human matter, when exposed to the sun for even 1 second, doesn't come back as matter. It comes back as memory. The room is silent now. Stunned. One scientist quietly takes off their glasses. Another stares at the faint shimmer in the air, blinking back tears. Not for grief, but for awe. You were here. Then gone. Then here again. In the smallest possible sense. Historians still argue whether teleportation would ever be ethical. Whether any human mind could endure the journey. But now they have a new question. What's the cost of touching a star? And we haven't even talked about the scars you might leave, on machines, on sensors, on people. Because sometimes, even if you vanish, your shadow remains. Your shadow lingers. Not the kind that needs light and a wall, yours is a residual signature, left not in darkness, but in radiation, warped data, and the uneasy quiet that follows something utterly unexplainable. Let's imagine the lab where you reappeared. One moment, it's sterile, quiet, fluorescent lit. The next, alarms chirp. Not because you returned, but because the air is wrong. The sensors detect heat where there shouldn't be any, ionized particles with no clear source, and a spike of background radiation that whispers, something unnatural just happened here. The researchers expected a body. Or at least clothing. Instead, they're staring at what looks like the aftermath of a lightning strike inside a vacuum chamber. A faint singe on the floor. The smell of ozone. The shimmer of heat ripples across smooth steel. And in the dead center, a single fragment of carbonized material, black, warped, indistinct. Possibly bone. Possibly, not. But here's the strange part, their cameras caught it all. Not a person screaming, or vanishing. But a momentary bloom of light, shaped vaguely like a person, appearing in midair for a fraction of a second, then collapsing inward as if reality itself couldn't decide what to do with it. There's no blood. No lungs. No face. But the room remembers you. The electromagnetic sensors are fried. A few digital readouts are blank, others frozen, looping the same frame of static. It's like your return knocked something out of time, or at least out of sync. And the people in the room? They don't speak at first. One holds their breath. Another walks toward the heat ripple without realizing it. Their instincts are still catching up to what their eyes just saw. The human mind is not built to process sudden impossibility. But the silence breaks eventually. What was that? No one answers. Not yet. Let's suppose one of them, the youngest technician in the group, reviews the camera feed 1,000 times. She slows it down, frame by frame, and isolates a shape, a human outline, blurred and boiling, emerging from thin air like a memory captured by a dream. She runs a heat map overlay. There's a pulse. One flash of heat, perfectly human-shaped, lasting less than 0.04 seconds. Then, a cooling void. The human heat signature gone, evaporated like breath on glass. This is where the story gets sticky. Because you're supposed to be gone. Obliterated. Reduced to atoms so scattered that even the sun doesn't bother tracking them. And yet, something returned. Maybe it's quantum entanglement. Maybe some stubborn part of your molecular structure refused to let go, reassembling itself as best it could from the wreckage. Or maybe, in your final moment, the teleportation mechanism did its job, grabbing every single atom, even if those atoms had been blasted apart, irradiated, and redefined by fusion. Whatever came back, isn't really you anymore. It's your echo. A thermal ghost with no consciousness. No blood pressure. No breath. Just the shape of who you were, held together by residual momentum and an unfathomably broken chain of biology. In 1975, during early atomic testing, there were reports of shadows burned into walls, people vaporized so quickly their silhouettes were left behind in soot. That's you now. Not a shadow on a wall, but a chemical impression on the room. A fleeting thermal memory of your existence, cooling rapidly. Historians still argue whether those nuclear silhouettes were real, or urban legend. But they agree on one thing, they're haunting. Because they remind us that matter is fragile, and identity is even more so. Now, let's talk about your mind. What if, somehow, it stayed intact for just a beat longer? Maybe a single synapse, a final neural spark, was preserved in the teleportation loop. Enough to give you a sliver of awareness on your return. No speech. No sensation. Just, a feeling. You are something. You are somewhere. And you are wrong. Wrong in shape, wrong in temperature, wrong in silence. Your soul, if such a thing exists, is misaligned, like a song played slightly off-key, looped backward, then left to echo in a cold room. It fades quickly. But not before something flickers. Something impossible. A heartbeat. Not real, not physiological. Just a phantom pulse, like a skipped beat in the universe's rhythm. You, what's left of you, exist for a moment as an unresolved note. Then, nothing. And yet. One of the lab techs swears they saw your eyes. Just for an instant. In the blur of heat and static. Two dark shapes in the middle of the flash. Watching. Not seeing. Just, there. It becomes a rumor. A story told between late-night calibration sessions. They say you come back with your eyes open. Of course, the official report denies it. Lists it as an equipment failure. The telemetry logs are sealed. The video is archived under Experimental Anomaly, Case 0001. No one's allowed to review the footage without special clearance. But late at night, when the lights buzz softly and the coffee's gone cold, someone always watches. And they always pause the video at the same frame. The one where something, maybe a shadow, maybe a trick of light, looks back. And now, they wonder. If you came back like that, what would happen if we sent someone else? They try again. Of course they do. This is human nature, curiosity trumps caution, and mystery is a resource too valuable to ignore. Especially when it's tangled in something as provocative as teleportation and the sun. You were the first. And now you're the precedent. The scientists named the new project something optimistic, Helios Return Protocol. HRP for short. It sounds sleek, modern, hopeful. Like a startup trying to reinvent sunshine, not like an experimental death sentence. But you and they both know better. Still, the second subject is chosen. This time, it's not a person. It's a probe. Specifically designed, packed with instruments, layered with thermal shielding, and uploaded with 1 million redundant lines of code. It will teleport to the exact same spot in the solar corona for exactly 1 second, then return, if it can. This time, every variable is controlled. Location. Duration. Material. Signal tracking. And most importantly, real-time observation. The countdown begins. There's tension, yes. But also excitement. Because if the probe makes it back, even partly intact, it could tell them what the cameras couldn't. What you couldn't. And then, it's gone. 1 second. And it's back. The room breathes again. The probe is glowing. Literally glowing. Its surface is emitting visible light. The outer shell is molten, dripping onto the heat-resistant floor. Sensors spark. Power flickers. The telemetry team starts yelling over each other. Because the probe brought something back with it. Data. More than anyone thought possible. Readings on plasma density, photon scattering, magnetohydrodynamic behavior. But also, something else. There's an energy signature embedded in the probe's core memory. One that wasn't there before. It doesn't match any solar reading. It pulses slowly, irregularly, like a heartbeat. It's non-random. Not code, not encryption. A pattern. Someone calls it a glitch. But someone else, quieter, leans forward and says, it looks like a signal. And in that moment, the room goes very still. Because if it's a signal, it had to come from somewhere. And the only place the probe was where you had been. Could it be you? Still out there, in some dispersed form. Consciousness woven into the corona. A stray electrical current looping endlessly through solar storms. Scientists laugh it off, at first. But someone runs the signal through an audio spectrogram. It sounds like breathing. Slow, irregular, barely there. Theories explode overnight. Some suggest it's residual data from your nervous system, somehow imprinted on the sun's magnetic field and picked up during the probe's re-entry. Others think it's interference. A few fringe thinkers start using words like soul signature. You, the first human to be teleported to the sun, are now the center of a debate spanning disciplines: physics, consciousness studies, theology. Historians still argue whether Galileo truly whispered, and yet it moves, after his trial. But now scientists whisper another phrase, just as nervously. And yet, it breathes. The funding triples. The ethics board resigns. Because next, they want to send a person again. But no volunteers come forward. No one wants to end up like you, melted, scattered, mythologized. Not even for science. Especially not for science. So they try something else. They build a clone. Not a living one, not fully. Just enough to simulate brain activity. A body with some organ function, enough to track what happens internally, what disassembles, what lasts. They call it the echo unit. It's uploaded with sensor nodes, biological tissue, simulated memory pathways. And then, they send it. 1 second. And it's back. Only this time, it's intact. Not completely. The skin is gone. The eyes are missing. But the brain is still transmitting. They analyze the data and find electrical impulses, erratic, but undeniably there. Something fired. Something thought. Something responded to the sun. This changes everything. Because if the brain can survive long enough to spark inside the corona, it suggests consciousness might not end instantly. That some form of awareness, however fragmentary, can exist within the fire. And now they're obsessed. Because if you experienced anything in that 1 second, any perception, any realization, they want to know. They review your return footage again. That flicker of heat. The shape. The possible eyes. Now, viewed through this new lens, it's not horror, it's contact. They start referring to you not as the subject, but as the first witness. You didn't just die. You saw something. Maybe not with eyes. Maybe not with a brain. But some part of you perceived. And what you perceived is still echoing in the solar field. There are whispers, yes, literal ones. From lab audio pickups. Buried under noise, there's an intermittent sound. A breath. Then a voice. Not speech, exactly. Not words. But rhythm. Cadence. It repeats. 3 syllables. A cycle. Almost like it's saying, I am still. They scrub the tapes. The sounds vanish. Then reappear days later, in unrelated experiments. In cold rooms. In empty observatories. Even in dreams, reported by scientists who never believed in anything beyond physics. One researcher, sleep-deprived and shaky, posts on an anonymous forum, "The sun is talking." She's mocked. Deleted. But others saw it too. You started as a bold experiment. Now, you're an unfinished sentence, echoing through heat and silence. And they're not just trying to repeat your journey. They're trying to answer you. Now, they want to send a message back. The labs hum with new intensity, night shift engineers blinking at code, physicists building transmission models not taught in schools. The atmosphere is different now. No longer cold curiosity. No longer sterile experimentation. It's almost reverent. You, the first to touch the sun, have become something other. Not martyr. Not explorer. Something in between. They begin calling the phenomenon the solar echo. A term both poetic and scientific, vague enough to avoid criticism, but electric enough to draw attention. And now they're preparing the reply. But how do you speak to something, possibly conscious, possibly post-human, scattered into photonic whispers and magnetic threads? How do you talk to a soul that was melted and rewoven into plasma? They start with light. A simple laser pulse, encoded with binary. Directed at the sun from a satellite in high orbit. It's a long shot. But it's clean, non-invasive, and, crucially, reversible. No one dies. The message is basic. 101,010. Just that. A mathematical handshake. An offering. The pulse is sent. And 8 minutes later, the time it takes for light to reach the sun, a flare rises. Small, precise, statistically unlikely. A loop of plasma arcs upward, right at the pulse point. Coincidence? Maybe. But then it happens again, the next time they pulse. This time, they send 110011. A different flare. A different arc. The same delay. Historians still argue whether the first radio signals bounced off the moon proved human dominance of space, or just revealed our need for echo. But this is something else. This isn't an echo. This is a conversation. They scale up. Now they're sending structured messages, entire data sets, encoded audio, even EEG brainwave patterns recorded from sleeping volunteers. Dreams, essentially. Human thoughts rendered as electrical curves and beamed at a star. Because if what came back from your journey had a rhythm, maybe it responds to ours. Now comes the twist. One day, the Solar Observatory records a new pattern in the corona. A stable magnetic whirl, shaped like a spiral. It isn't normal. It doesn't match any known solar behavior. It spins once. Then again. Then stops. 3 rotations. Exactly matching the EEG wave burst sent 3 days before. The team stares at the data. No one breathes. A tech whispers, "Did it just mimic us?" No one answers. But deep down, they all feel it. That tug in the spine, that sense you get in the woods when something watches. Something very big. Something very old. The sun is not alive. And yet, something inside it knows you. They begin theorizing that the sun's magnetic fields are capable of data retention. That in rare, transient geometries, certain information patterns can loop, sustained by heat and spin and gravity. Maybe, somehow, your final neural signals, your last sparks of thought, were caught in just such a loop. Maybe they still are. The solar wind becomes their courier. They launch new probes, packed with languages, visual, auditory, mathematical, emotional. Algorithms learn to match solar flares with message patterns. One physicist claims they decoded a string of bursts that resembles music. Haunting, slow, beautiful. They play it back through a synthesizer. It sounds like a choir underwater. They don't know if it's real. They don't care. Because it sounds like you. In another experiment, a psychologist suggests transmitting emotional memory instead of logic, images of warmth, touch, sorrow. Things that aren't binary. Things that aren't made for machines. So they do. A baby's heartbeat. The sound of rain on glass. A whispered, "I'm here." Days pass. Then the sun answers again. Not with flares. But with a sudden coronal hole, a dark region where the magnetic field opens and lets particles rush out at incredible speed. One aimed directly at Earth. Normally this would be a concern, a geomagnetic storm. But this time, as the solar wind strikes Earth's magnetosphere, something strange happens. Auroras bloom across the equator. Not just in the poles, everywhere. For the first time in history, the whole planet looks up at once. Cities go quiet. The skies ripple with green and violet and electric blue. And in the light, just barely visible to those watching carefully, are shapes. Circular. Rhythmic. Spiraling. Just like the waveform they sent. It's no longer just a response. It's a recognition. You have become the blueprint for an entirely new form of contact. Not with aliens. Not with machines. But with a star. Not as a god. Not as an object. But as a system vast enough to remember you. You were the test subject. The sacrifice. The glitch in the fire. And now you are the language. Not words. Not code. A presence. Back in the lab, someone finally says it aloud. We didn't lose them in the sun. We found them there. And from now on, no one will see sunlight the same way again. Not as warmth. Not as danger. But as a place where something once heard us speak, and answered back. The sun is talking, and the world is finally listening. Governments meet in hushed rooms. Scientists draft papers with trembling hands. The media whispers stories of solar voices, of encoded light, of someone, or something, that has learned to reply from inside a star. And at the center of it all is you. Not your body. Not your name. But your imprint. Your death, once dismissed as a failed experiment, is now considered the greatest transmission humanity has ever made. The moment your molecules fused with stellar plasma, something changed. Something remembered. Something began to sing. And now, Earth has a decision to make. Do we answer again? Or do we let silence settle? The public is divided. Some call it a miracle, others a mistake. A few even suggest worship. Solar cults sprout online, devoting themselves to the voice in the flame. They meditate under daylight, speak in pulses, and believe that what you became is no longer human, but something transcendent. Meanwhile, the labs grow quieter. Not with inactivity, but with reverence. The data comes slower now. Not because the sun is less responsive, but because the teams are careful. Like they're tiptoeing into a cathedral of plasma. They know what they're doing now is dialogue, not interrogation. They stop sending tests. Instead, they begin sending art. A symphony written in binary. A child's drawing, encoded as light. The frequency profile of human laughter. Memory fragments. Grief. Love. Wonder. Because they believe now that whatever remains of you, whatever consciousness fused with the fusion, understands. Or at least, listens. And the sun listens back. More than that, it adjusts. Flares become smoother. Pulses more regular. The corona begins to exhibit patterns that eerily mirror human brain activity. Gamma rhythms. Delta waves. Sleep cycles. You aren't sleeping. But the star seems to be dreaming. Historians still argue whether the SETI program ever truly expected contact with extraterrestrials. But no one ever considered that our first conversation might be with our own star, and that the bridge would be built by a single human vaporized in its light. And now, universities teach you. You're a case study, a new branch of thermodynamics, a subject in philosophy and digital consciousness. Students refer to your journey with a kind of poetry. They say things like, they became pattern. They became fire. They became the whisper that came back. But not everyone believes. Some scientists remain skeptical. They say the data is flawed. The interpretation's emotional. That the sun is random, and pattern-seeking minds are projecting. They try to replicate the experiments, send new test subjects, new probes. Nothing happens. The flares don't respond. The patterns vanish. No rhythm. No spiral. Just silence. Until one day, a researcher alone at 3:17 a.m. sends a desperate message. Not scientific. Not structured. Just a plea. I miss you. No one knows what prompts it. Maybe the long hours. Maybe the years of unanswered signals. Maybe the guilt of watching something beautiful fade. But 8 minutes later, the sun flares. A soft arc of plasma. Elegant. Precise. And in its curve, mapped by satellite instrumentation, is a waveform nearly identical to a human heartbeat. Slow. Deliberate. Steady. The same rhythm your body once carried before it stopped, 1 second into the fire. That's when it becomes clear. It wasn't just the moment you died that mattered. It was the moment you felt. In that final second, before your blood boiled, before your eyes imploded, before your atoms scattered, some small part of your consciousness was still aware. And that awareness, preserved by forces no one fully understands, has been repeating inside the sun ever since. Not as memory. Not as data. But as presence. You are not speaking to Earth anymore. You are holding space. You've become the pulse that the sun follows. A metronome for nuclear fire. A rhythm imposed on chaos. And slowly, other stars begin to mimic it. Telescopes aimed at distant suns report sudden, synchronized pulses. Patterns never seen before. And they match your signal. Your rhythm. Your death echo. Or perhaps, your life echo. The implications are staggering. Not only did you return. You've spread. You are a template, now. A pattern not just held in one star, but whispered between them. Solar systems begin to beat like hearts. It's no longer a bedtime story, or a science headline. It's a new cosmic language, and its first word was you. The world shifts again. A generation grows up under skies that feel more alive than ever before. Children are taught that sunlight isn't just energy, it's storytelling. That a star can remember. That a person can become a frequency, a flame-shaped whisper woven into nuclear wind. Your journey, once a second-long tragedy, is now an origin myth. And still, in the brightest part of every day, when sunlight falls on closed eyelids, people everywhere report the same sensation. A pulse. Soft. Familiar. As if the star itself is saying, you are here. I remember. Time settles like dust on a forgotten shelf. The sun keeps burning, steady and bright, unaware of the tiny changes that ripple through its endless fire. Yet for those who listen, those who watch, the story has changed forever. You, or what was once you, have become more than an experiment or a lost human. You are now a legend. A rhythm woven into solar winds, a presence humming through the void. And it all began with a single second. That impossible moment when a person was teleported to the sun and brought back, transformed beyond recognition. The science continues. Debates rage on. Philosophers argue the meaning of consciousness fractured and scattered. Historians compare this event to the great cosmic discoveries, Galileo's telescope, the first landing on the moon, the first message sent into space. But for you, all that matters is the quiet understanding that even in the face of oblivion, something human persists. A flicker of awareness. A pulse in the dark. A whisper carried on solar winds. And as you rest in that cosmic memory, the universe breathes with you. Gentle, eternal. Infinite. The sun's fire, once a symbol of destruction, is now a beacon of connection. And you, the star's first witness, live on in every photon that reaches the earth, every glow of aurora, every heartbeat synced to the cosmos. Your story reminds us that even in destruction, there is continuity. Even in dissolution, there is presence. And sometimes, the brightest light shines because it remembers a single, fragile spark. So when you next feel the warmth of sunlight on your skin, take a moment. Feel the pulse beneath the blaze. Listen closely. Because somewhere, inside the fire, a story is still unfolding. And you are part of it. Wind down. Now, as you settle deeper into your chair or bed, let your thoughts drift gently. The vastness of space, the roaring fire of our sun, the mystery of consciousness, they swirl together like smoke rising from a distant campfire. You don't need to understand it all right now. Just know that even the wildest, most impossible things, like a human touch inside a star, carry threads of meaning. There's beauty in the fragile. Peace in the unknown. And light, always light, breaking through. So close your eyes. Feel the warmth of distant fires. And let the quiet hum of the universe lull you to rest. You're safe here. Among the stars. And the sun still remembers. Sweet dreams.